Individuals or groups in the organization are charged to determine the root cause of a defect and correcting it. Sometimes solutions can be complex, and other times they can be known but require long lead times to implement. There are a wide range of problem-solving tools available to accomplish these aims. We will highlight some of the premier techniques in this lesson. When the need for corrective action is identified, management must consider if the root cause analysis has identified the full scope of the problem and that the corrective action is suitable, adequate, and effective. Suitable implies that the solution is acceptable. Adequate implies that the solution is sufficient. Effective implies that the solution works. The 5 whys approach is described as asking the question why 5 times. An example might be, the wait time at the drive-thru is too long. Why? There are a lot of people in the line. Why? People like the food. Why? It tastes good. Why? The food is chicken. Why? It takes longer to prepare. It cannot be sold undercooked. So the root cause is that the store does not have enough cooking capacity to meet demand. Sometimes we can find the root cause quickly. Other times we may have to ask why even more times. We keep asking why until we reach the root cause. Cause and effect diagrams graphically display potential causes of a problem. They are very effective in stimulating thinking during brainstorming sessions. Cause and effect diagrams also help us best understand the relationships between potential causes. We can also use to organize which potential causes have been investigated and which proved to significantly contribute to the problem. It is common for people to jump to conclusions without studying the causes. Additionally, avoid targeting one cause while ignoring others and/or acting on symptoms. Cause and effect is useful when there are a large number of causes or we have trouble understanding the relationship between the potential causes. A common application of the cause and effect is the Fishbone Diagram. Generally, the 4M, which stands for manpower, material, method, and machine, version of the Fishbone Diagram will suffice. The example here deals with a defective lamp. Our process begins by, first, reviewing the focused problem statement. Next, identifying possible causes. Sort each cause into reasonable clusters. Choose a cluster and label a main bone. Develop and arrange bones for that cluster. Develop other main bones. Look for causes that can be verified with data. And finally, add a title, date, and contact person. Pareto charts are used for categorical data. The height of the bar represents the relative importance of the problem. Bars are arranged in descending order from left to right. The bar for the biggest problem is always on the left. Pareto charts are useful in understanding the pattern of occurrence of a problem. We are able to see the relative impact of various parts of a problem at the same time. The largest contributors to a problem are easily seen, and this is where our effort should be focused. We often apply the Pareto principle to these tools. This rule states that 80% of the problems can be solved by addressing the top 20% of the issues. If all the bars are roughly the same height, we should look for another tool to analyze the data and determine where to focus our resources. Pareto charts can sometimes be misleading. The chart here is generated where each defect carries the same weight. Criticality is this may be a safety concern or a quality issue. We can address this issue by a weighted Pareto chart. In this case, each frequency is multiplied by a criticality factor. In this case, we take the previous chart and multiply each frequency by a criticality factor. Now, surface split is weighted the highest at 40, followed by delamination, color, and veneer, each at 15, and then planarity at 10 and thickness at 5. See how the prioritization changes? Surface split appears to be the issue that deserves our attention, followed by delamination and color. Another technique developed by Henry Ford is the 8D problem-solving process. 8D is used in group problem solving. The 8D process has the following steps. First, establish the team. It is recommended that you recruit from many areas of the business. A diverse team will enrich the process. Second, describe the problem. Identify the problem in terms of the customer's problem and in quantifiable terms. Develop a plan for containment. Determine an interim solution to stop the bleeding and protect the customer. Identify root cause. Use some of the tools discussed in the module to assist you. Develop alternative solutions. Make sure your solution will eliminate the root cause. Make sure there are no risks involved. Implement the corrective action. Provide a plan with controls to monitor and ensure elimination. Part of every effective corrective action is follow-up and audit to confirm the solution was effective. Make sure to do this. Prevention is just as important as correction. Aim toward long-term solutions as opposed to quick fixes. Celebrate your successes. Every problem has something to teach us about what to do and what not to do. We should be willing to acknowledge and discuss these. Fault tree analysis is a systematic methodology for defining a single undesirable event and determining all possible failures that could cause it. The undesired event is placed at the top of the fault tree. The fault tree diagram is an easier and faster method of analysis compared to FMEA because it has a specific focus. Fault tree analysis is extremely useful during the initial product and design phase. It can also be used for safety hazards or requirements, system reliability, corrective actions, or troubleshooting. Fault tree analysis is preferred over FMEA where there is a safety or operating issue. Fault tree analysis uses logic gates to determine the overall reliability of a system. There are numerous fault tree analysis symbols. These are provided in technologies designed to create and characterize fault tree analysis investigations.